we have been doing up to flotation we have done, right? In fluid mechanics,
Yes, sir. हाँ सर.
buoyant flotation we have done. Okay. Today we are supposed to start Archimedes principle, right?
Yes, sir. Yes.
This we have done in the last class. Archimedes principle. Now it says that when a body is partially or fully immersed in a fluid, then it experiences an, an upward force that called as also buoyant force. Buoyant force, which is equal to the weight of fluid displaced by the body. So Archimedes gave a new definition or new formula for buoyant force. He said that the buoyant force is equal to the weight of the fluid displaced by the body. That means if a body is able to displaced the fluid whose weight is equal to or more than its own weight, its own weight, then it will float. It's a very important concept. Earlier we have discussed that the body will float when the density of the body is equal to density of the liquid. But only density does not matter, because we see that a ship made of iron is floating on water. What iron density is more than water. So only density doesn't matter. The iron ship is floating on water because it is displacing lot of water, and the displaced water weight is more than the weight of the ship also. That's why a ship made of iron can swim on, can float on water. We also can swim in water. Our density is also more than water, but if we want to swim, we with our hands or with our legs we try to displace water, And if you are displacing sufficient water whose weight is more than your weight, then you can swim. If you are not able to displace as much water that is equal to your weight, in that case, you will sink. That is basically Archimedes' principle. You understand, Neil?
Yes, sir. Understood.
Okay. Okay. So the buoyant force is basically weight of fluid displaced by the body. Displaced by the body. Formula will remain same. There is no change in formula. Formula, we know that this is the density of liquid and uh, volume of immersed part, inside part of the body into G. This is already, I have taught you the formula of buoyant force, very important to understand. Density of, again I am writing, liquid multiplied by volume of immersed part of body into G. It is also saying that if a body is, let's suppose, immersed in some kind of liquid, if a body is immersed in some body is immersed in some kind of liquid, then there are two forces acting on it. One force is the buoyant force, other force will be its own weight. So the net force, if I say, what is the net downward force? If I say here, net downward force, that we also call as apparent weight, because we know that whatever force is acting downward, that is the weight. So we say that apparent weight of a body inside a fluid, inside a fluid. This we write as W dash, and that you can say is a downward force W minus buoyant force. If body is having some density H sigma, and uh, rho is the density of the liquid. So if I say weight of the body, so I will take the density of the mass is density into volume. So density of the body into its volume into G. Whereas in buoyant force, we take density of the liquid. We say that density of the liquid into volume into G. This is also weight. In weight, we take the density of the body. Sigma, I am writing density of the body, volume V, and the value of G, I'll write as G dash. This is here density of the body into volume into G minus density of liquid into volume into G. Now V got cancel here. This you can bring this side also. So G dash, what you are getting, density of the body will be divided here minus here density of the liquid into G divided by density of the bond. This you can cancel. So you get here G minus density of liquid by density of body into G. G you can take common. So the value of G dash, that is apparent value of G inside any liquid, what the value of G will take? That is G in bracket outside 1 minus density of liquid divided by density of body. This is called apparent value, or also we call effective value. Effective value of G inside a fluid. You understand, Neil?
Yes, sir.
Please write it.
Yeah, sir. Done.
Okay. So it means that the value of G will change. And if you see the formula, it says the value of G inside any liquid is actually G minus something. G minus something means one thing is sure, that it will not be equal to G. It will be slightly less than G. Why? Because it's very simple to understand that it is actually subtracting G minus something. So if you are subtracting something, it does mean that its value is going to decrease. Okay, so that's why you also might have felt that something appears, little light inside a liquid. Even a heavy object, if you try to lift inside some kind of liquid, it will appear very light, because the value of G is here there decreasing. Okay, Neil?
Yes, sir.
Also, if we write here, this is equal to, if I say real weight minus B. So it means B, I can take this side. It becomes here weight minus weight dash. This is called apparent weight. This is called real weight. So this is another formula to find the buoyant force. It's actual weight of the body in air, actual weight of the body in air minus apparent weight, apparent weight of the body in any kind of fluid that you are taking. Any kind of fluid. So if the what was the actual weight of the body and what is the weight of the body inside the fluid, that means you first you imagine the what is the body of the weight of the body in air. Let's suppose this weight is W. Now you take the some kind of fluid there, and there you just keep the body, and again you keep the weighing machine here to check the weight. Here also see the weight, here also see, we keep the weighing machine. So what is the weight inside you are experiencing, what is the actual weight, you subtract. So that is called weight. So this is also called as B equals to loss of weight. B is called as loss of weight of the body. That means what is the difference? Loss of weight of the body, loss of the weight of the body inside a fluid. So कितना weight में difference आता है air और उस fluid में, वो अगर आप निकाल लेते हो तो वही उस fluid का buoyant force है. उस fluid ने कितना upward. So कितना buoyant force है वो आप बता सकते हो. तो buoyant force निकालने का एक अच्छा ये तरीका है जो आर्किमिडीज ने दिया था कि आप पहले उस बॉडी का वेट एयर में निकाल लो कितना है, उसके बाद उस बॉडी को किसी लिक्विड में रखो और लिक्विड में उसका आप वेट निकाल लो. मान लो कि एयर में वेट है 20 न्यूटन और किसी लिक्विड में आप ले गए तो वो वेट हो गया 18 न्यूटन. इसका मतलब डिफरेंस कितना आया, 2 न्यूटन का. तो वो 2 न्यूटन क्या है, वो 2 न्यूटन लिक्विड का लगाया हुआ बुएंट फोर्स है, क्योंकि वो उसने वेट 2 न्यूटन लूज किया जब आपने उस बॉडी को उस लिक्विड में डाला. ये पूरा इंटायर जो कंसेप्ट है आर्किमिडीज प्रिंसिपल का यही है. समझ में आया नील?
यस सर, समझ में आया.
ओके. अब इसके कुछ एप्लीकेशन देखो, क्या एप्लीकेशन है, मान लो क्या क्वेश्चन कैसे नीट में पूछते हैं इससे, दैट विल डिस्कस. First application is if you try to find the relative density of body, to find relative density of a body, relative density of a body. First, you know what is relative density is nothing but density of body divided by density of water. Density of body divided by density of water. Now, as I told that the buoyant force is uh, loss of weight, loss of weight inside a fluid. So what you take here? You take inside water. And real weight is what? W is actual weight of the body, weight of body in air. So if I take the ratio, let's suppose this is equation 1 and equation 2. If I take equation 2 divided by equation 1, so this I'll get here, weight of the actual weight divided by buoyant force is nothing but weight of body in air divided by loss of weight inside water. And this body is completely immersed. पूरा का पूरा हमने इसको वाटर के अंदर इमर्स किया हुआ है. So weight of the body in air हो जाएगा density of the body into volume into g. और buoyant force हो जाएगा वाटर कितना लगा रहा है तो डेंसिटी ऑफ वाटर into volume of the body into g. So here Vg cancel. This will be density of the body divided by density of the water. And I know that by the formula of relative density, density of body divided by density of water. Okay, density of water is nothing but relative density of body. And formula क्या हमें मिला है right side में? We have got, it's very simple to find weight of body in air. Just you need a weighing machine to find the relative density. Just you check the weight of the body in air and how much is the loss of weight when you are putting it inside water. Loss of weight inside water. Loss of weight inside. This is the formula for relative density of a body. For example, let's suppose weight of the body in air is 20 Newton and weight of the body in water becomes 18 Newton. And I have to find the relative density. So relative density formula is what? Weight of the body in water, that is 20. And now it is becomes 18, so it is loss of weight. How much weight has been lost? So 20 minus 18. That means 20 by 2. Answer is 10. You got it, Neil?
Yes, sir, I got it.
Okay. Let's write this first application.
Yes, sir. Done.
This example also you write, okay? Written?
Yes, sir. Yes, sir.
Oh, fine. So next application, they say sometimes to find the relative density of a liquid. Earlier we found that of a fluid. So it's very easy now. That means relative density of a liquid will be the density of liquid divided by density of water. Now, first you try to find the loss of weight. Let's suppose let a body is let a body is immersed in water. So the buoyant force applied by water will be very simple. It is loss of weight of the body in water, because buoyant force is equal to loss of water. Now, let's suppose if the body is immersed, if the body is immersed in uh, that liquid whose relative density you have to find, whose relative density you have to find. In that, if you immerse the body, then the buoyant force applied by the liquid will be very simple. That is loss of weight of body in given liquid. Now let's take this as equation 1 and equation 2. Again, you divide 2 by 1 by equation 2 divided by equation 1. So what do you write? Buoyant force liquid by buoyant force water. That is equal to this is loss of weight in liquid divided by loss of weight in water. Now, here, if you see, buoyant force by liquid will be what? It is density of the liquid into volume into G. And this is density of water into volume into G. This is cancelled. So what you get here? Density of liquid by density of water. And that is actually relative density of liquid. And that is how to find, very simple. What is the loss of weight in liquid? Loss of weight in liquid divided by, this is loss of weight in water. So if you try to find loss of weight in liquid and loss of weight in water, then you can find the relative density. For example, if I say I have a body whose weight in air is 20 Newton. If I keep it in water, its weight becomes 18 Newton. If I keep in some kind of liquid, its weight becomes, let's suppose, 15 Newton. So what is the relative density of liquid? So you see how much weight is lost in the liquid. From 20 it becomes 15. So you write 20 minus 15. Divided by loss of weight in water. In water it becomes 20 to 18. That is 20 minus 8. This is 5 divided by 2. So answer is 2.5. 2.5 is the jelly density of the liquid. Understood, Neil?
Yes, sir. Understood.
Yeah. The second application, please write.
Yes, sir. Done.
Okay, this example also you write, okay?
Okay, sir.
So these are the two applications. Few questions are shared like uh, let's suppose one any liquid is there and a body is not completely immersed, is partially immersed inside a liquid. So if I say how much fraction of the body is inside or how much fraction of the body is outside, okay, fraction of body inside the liquid, inside the liquid, it means that V in by total volume. Or if they say a fraction of uh, body or fraction of volume outside, so you can say V out by V, or you can also find total volume minus volume of inside. That also you can do. How to find these things? This is also a good application. First, you write that density of the liquid, let's suppose, is rho L. And density of the body, I am writing here sigma of V. If the body is floating, it means that the buoyant force is balancing the weight of the body. Okay. That means the body is in equilibrium. So I can say that body is in equilibrium. So buoyant force is equal to the weight of the body. Buoyant force will be equal to the weight of the body. Buoyant force you can write as the density of the liquid multiplied by what part of volume, that is inside only, into G. And the actual weight is the density of the body multiplied by total volume, because we are trying to find the weight, so we have to take the complete volume. G you can cancel. So here you see that if they ask what is inside fraction of the volume, V in by V, then V in by V you can write as density of the divided by density of the liquid. This is the way to find fraction of volume that is inside the liquid. If you say percentage of volume, percentage of volume inside the liquid, then the fraction only you can multiply with 100. That is V in by V into 100. That is density of the body by density of the liquid into 100. Understood, Neil? Let's copy.
Yes, sir. Done.
Okay, like I'll give you one example. Let's suppose I have a body whose density is given 0.4. And if this body is immersed, if the body is immersed in water, whose density you can consider as 1. This is 0.4 gram per centimeter cube. This is also gram per centimeter. Then, and if I ask what is the percentage of volume of body outside water, outside water. Let's suppose they are asked. So first we try to find the volume of inside divided by total volume. And this we know is the density of the body divided by density of the liquid, which is here water. Density of the body is given 0.4 and that is 1. It means here 4 by 10, that is 2 by 5. So 2 by 5 of total volume will be inside. If I say what is the outside fraction? What is the outside fraction? So you can subtract from 1. 1 minus whatever is remaining, that is outside volume. So 5 minus 2, that is 3 over 5. If I say percentage of volume outside water. So whatever fraction that you have got, 3 by 5, you can multiply with 100. So it will be cancelled. So 5, 20. So what you get here, 20 times 3 is 60. So 60% is outside and 40% will be inside. You understand? If you have any doubt, you can ask. Then I'll give you one more example. Plus you solve this, you understand this and properly write. Neil, I'm not able to hear. If you are, have you copied this? Done?
Yes, sir. Sorry, I was on mute. I did not realize.
Okay. So this concept is properly understood now. In short, you can also say that if I say, let's suppose a body is having density 0.5. 0.5 means if you will keep it, in water, then 50% will be inside, 50% inside and 50% outside. In short trick to know, if I say that density of the body is 0.2, 0.2 means it will be 20% inside water. And if 20% inside, then definitely 80% outside. You understand?
Yes, sir.
So by this trick, you can solve the question, what is the fraction or what is the percentage of the body that will be inside or that will be outside. So this is, we have completed working principle today. Now, next topic will be now fluid dynamics, that is flow of fluids. In that, we study about Bernoulli's theorem and its application. Okay,
Okay, sir.
thank you.
Thank you, sir.